Hey Math 1, review topic number 5 is describing features of functions and then using them to make tables. So let's take a look at this first example right here. I don't see any exponents, so I know that this is the equation of a line. So this is linear, and the key features for all linear equations, okay, have two special key features. The first one is the starting point. Okay? The starting point, or you could even just call it SP, has an x value and a y value. The second key feature for a line is always the slope, which we could use the letter M to represent, or we could say delta y over delta x. So let's go find these key features. The first thing I'm going to do is find the slope, and the slope is always in front of the x. So this -2 right here, okay, this is the slope, and I'm going to write that as -2 over 1. Now the starting point needs an x value and a y value. Sometimes the x has parentheses, okay, and there are no parentheses. This is the short version, the slope-intercept version. The starting input is 0. The starting output, or y value, is always alone, and that is going to be a +7. Okay, so the value that is alone is the y value. The x value is by x, and in front of x is the slope. I'm going to put this starting point over here in my table. Now to create more points or more values, I need to do the delta y and the delta x. The delta y is -2. So on the y side, each time we're going to subtract 2. Delta x is +1. So on the x side, we're going to +1 add 1 to each value. This negative sign does not belong to both, only to the 2. 7 minus 2 is 5, minus 2 makes 3. 0 plus 1 is 1, 1 plus 1 again makes a 2. Okay. Key features are starting point and slope. Is this line increasing or decreasing? Okay. And the way that we know that is by examining the slope. So this slope right here is negative, so the line would be decreasing. It's going to be going downhill. And the reason I know that is I'm going to say because the slope is negative. All right, let's go examine the next equation here. This equation is also linear. Okay, I can tell that because there's no exponent, so this is a linear equation. This one is a longer version, so this must be point slope. The same two key features apply. We need a starting point, and the second key feature would be the slope. Okay, I'm going to do the slope first. In front of the x is where you find that slope. So the slope right here, you look at the sign in front, it's a positive. The slope is 1 over 3. It's positive, so delta y is 1, delta x is 3. The starting point, okay, I need an x value and a y value. To find the x value, you go look at the x. But remember, he has the switcheroo. So this starting x value is -5. And the y value is always the one alone. It might be in the beginning. They sometimes put it at the end, like they did up here in this equation. So the starting output is 10. So in your table, your starting input is -5, the starting output is 10, and you're going to use this slope to create more points. On the delta y side, you are going to add 1 each time. And on the left side, on the x side, you're going to add 3. Okay, remember, linear means arithmetic. And arithmetic, okay, needs an adding or subtracting pattern. And slope is a two-sided pattern. So let's go ahead and add 3 to -5. That makes -2. and add 3 again makes positive 1. 10 plus 1 makes 11. Adding 1 again would give us a 12. So is this line increasing or decreasing? Okay, we're going to look at the slope for that. This line, okay, would have a starting point, and then I would go up 1 for the rise and 3 to the right. Okay, this line is definitely increasing. And the reason I know that is because the slope is positive. It doesn't matter if it's a fraction or not, it's going positive, it's going uphill. Okay, this last example has an exponent. And when you see an exponent, it means that it's going to be exponential. And exponential graphs, remember, look like a curve. They have multiply or divide patterns. Okay, so the key features are going to be a little different. You could say starting point, or some people like to just say the starting output. The starting output is always this value right here. So the starting output is 2/3. Some people like to say the full starting point, and that would be 0, 2/3. The reason x is a 0 is because there's no value by x. So in this table, you have 0 and you have 2/3. The second key feature with exponentials is not a slope. It's not an adding pattern, because remember, we have a multiply or divide pattern. Okay? And I'm going to say that the pattern, or you could say the common ratio, okay, is multiply by 5 each time. So in your table, on the right-hand side for the y values, you need to multiply by 5 each time. 2/3 times 5 would be 10/3. Multiply by 5 again, and you get 50/3. Please make sure you know how to do that in your calculator. Now for exponentials, okay, on the left-hand side, we just add 1 each time. But the pattern is happening over here. We just have values of 0, 1, 2. In terms of increasing or decreasing, okay, we don't say anything about a slope. This is a curve that's getting multiplied by 5. The numbers are getting bigger each time. The curve, okay, is definitely going up. So we're going to say that it's increasing. And we don't want to say anything about slope. We're going to say it's the pattern. It's increasing because we're multiplying by 5 each time. Some people like to say because we're multiplying by a whole number. Okay, great job. Now your turn to do some practice.